Hi. Once again, I am not the author. I'm presenting this work, though, for them. Their flight was canceled due to weather in Boston. So this is work on synthetic to real adaption with generative correlation alignment networks. So advances in deep learning are often limited by the dependence on massive training data. The ad hoc collection and annotation of training data for various computer vision tasks is cumbersome and costly. For example, of course, I mean, we know the huge data sets like ImageNet and COCO have tons of, require huge amounts of data, and getting that data set up is a huge task. Using synthetic data has become a focus of a lot of works recently. Most of the works focus on generating synthetic images using CG techniques, and the advantage of synthetic data comes from the fact that 3D CAD models are freely available, and you can generate huge amounts of data by rotating them. And this generated data can be automatically labeled because we know what the original objects were. Here we see some lists of some of the existing works in this area, but a lot of the a common issue in most of these works that, well, in all the works that have come previously, is that there's a domain discrepancy between the synthetic data and the real data. The discrepancy is introduced by having these non-photorealistic scenery with the synthetic image, and the mismatch between the foreground and the background in these synthetic data. To address this issue, the authors proposed a deep generative correlation alignment network to bridge the domain discrepancy between in deep feature space. As an input, the model takes a generated image from the CAD model. It takes the synthetic data from the CAD model as well as labeled real data as input. And then the output is a generated image which preserves the shape from the synthetic data but also has background and textures from the real domain. The network they used is based off of WACV18. The main focus, though, is to use the hidden feature layers to achieve two goals. In particular, the naturalness, they have naturalness loss, which is applied to align the correlation of the hidden features between the generated data and the real images. And then they have a shape preserving loss, which is used to keep the shape of the synthetic data when they apply it and create this new generated image. We see here several of the rendered results. In particular, you could see cases like with the CAD model of the airplane, where the airplane still exists in the image, but it's placed in something that looks kind of skyish, as you can tell, with textures and everything. And similar cases for the remaining data. They then took this and trained off-the-shelf classifiers like AlexNet and such using these rendered images and produced better results, particularly in comparison with other models which were used to have domain adaptation between the synthetic images and the fake and the real images. And so you can see here several of their results and improvements in every case, I guess. Some additional results where they showed that theirs worked best as well. And finally, we have some lists of where you have just using the original CAD model and using the synthetic data from that, and taking having the classifier work on that and having incorrect answers in most cases, and then in most of these cases that they're showing here, and then using the newly generated data, it in most cases improves the classification result. A couple cases it doesn't, but the overall goal is accomplished there. And they'll have their poster up later, so thank you.